Hi guys, I'm Rajesh Chandrashekaran here. Good morning or good evening to you guys, depending on where you're joining from. I work as VP of Engineering here at BukuWarung and been in the industry for about almost 24 years. Worked in a lot of companies like Google, Amazon, Microsoft, and a lot of Indian startups. So today I hope I can have an exciting session to discuss around uh, monolith versus microservices and sort of what is it that you guys can expect from this presentation is maybe from the point of view of experience for a person who's seen these how these are done not only in large organizations but also in startup, and also to kind of give you a flavor of overview as what life will look like when we go down this path. uh, and the target audience for this presentation, I would say possibly anybody who's done microservices, who's getting into microservices, been working at monoliths, maybe like 2 to 5 years experience, or even the latter part of the presentation where we'll talk about resiliency and scale. I would say might be for folks slightly more senior. There'll definitely be something of interest for folks to take away from this presentation, and then if there are any questions, I can cover that in the Q&A. So what is it that we will cover today? Essentially, the first part of the presentation, I really want us to just recap uh, on what it is that monolith versus microservices, what do you get from these things? Uh, and I want to try to reach like the end goal of this presentation to get people to understand, when they're making this decision, whether they want to go down a path of microservices or monolith, exactly what are they getting into, right? uh, Sometimes people hear of microservices, they think it's all cool, and but there are some things that come in, and we look at sort of the trade-offs that you have to make uh, to kind of reach that. The second half of the presentation, we will actually look at a lot of actual examples to scale, taken from some of the startups I've worked at, and we look at things from basic, like services working all the way up to like internet scale. I have some few examples there, and then we can kind of deep dive into that a little bit more. So let's just recap what you get with the monolith. And this is maybe like a simplistic view, just to keep the subject simple. It might also be repeat information for a lot of people who already know these things. So basically, monolith, as it says, it's, as you can see in the picture there, you have like one block. A lot of the things are running in that block. It's basically, yeah, very likely that you have a relational database that you're starting with. Maybe you didn't have a scale considerations to start with, and all if you're doing like a simplified version of like a e-commerce, maybe your product, customer orders, whatever it is, in a simplistic view, is running in that piece of monolith together. It is fairly easy to manage and deploy, and it is still possible when even when you do the monolith, that maybe you're just getting started, you can still break it into modules, and this is what maybe you can call it as a modular monolith. And people have been doing software development for like quite 30-40 years now, and you still can break up software into components or modules. So generally, when I talk about monolith, I would be talking about like a modular monolith. So you can still do a lot of the best practices like unit testing. Those things can still be written for quality. Nothing really prevents you from doing those parts of it. And the other considerations are maybe the monolith uh, doesn't really scale for you beyond a point, and which might be okay for that problem statement. But you still need to be careful about like missing indexes, your databases are kind of going down. You can decide whether you want high availability or not. The reason I say you can decide, for instance, I might have an internal tool within my organization, and I have very few customers. it might be fine. Like downtime might be perfectly fine. And so I would say like, okay, I wrote this, and I would say that, okay, maybe if the database goes down, and I can restart it in the night for some kind of repair, that would be fine. Maybe I have a slave database if I want to make sure that, okay, the master kind of goes down, something is there. Maybe I'm backing this up. Maybe if I want a little bit more than that, I have multiple instances of application server running. So it all is very contextual, but still for the type of scale I'm looking at, it could be fine, right? So, and the thing from an engineer's perspective, uh, once you've decided whether you want high availability or not, or to what extent, from programming point of view and troubleshooting, because all the code is in one place, uh, it's easy to put a breakpoint and step through the code. You can actually walk through the code fairly easily, and so uh, all the context is pretty easy to follow for one single person. Even from manageability and deployment point of view, you can easily spawn additional environments in QA prod, because there aren't so many moving parts. It's slightly easier to do that. And overall, life is simple to some scale. Right now, it depends on how large your team is. Maybe if you have a small team, maybe 10, 15 people. I've seen people go all the way to 50 folks also. But at some point, you'll start finding challenges from how you can manage this, not from just from scale point of view, but just that people are stepping over each other's toes. Your releases are kind of getting intersected, and there are mechanisms around that. You can use things like feature flags, but the monolith is something that has some of these characteristics. So if I have to just recap what you kind of get in microservices. Now, before I really talk about microservices, I just want to talk about the philosophy of services themselves, and sort of where they started. Uh, and if I think about it, it's mostly was to come from an organizational context. So you have a large piece of software, and you said, hey, this is too big to handle. So can I break up the software such that uh, it is like sizable enough chunks for like maybe like a two pizza team, right? This is kind of where the genesis of a lot of the work that some of the early e-commerce players started with, when they started with services. And it was a way to manage complexity, and also to put like uh, like a system of record in place, and some boundary around that, to say that this is how all accesses that come to the data uh, base, or regardless of whether it's SQL or no SQL, how you kind of access that, you come in through this common pattern, right? And that is where it's really started. So you see things like domain-driven design, where I might have like a returns service, that I have a returns team. So in some sense, the software would follow the organizational architecture. So it was really not, it didn't come as a software concern. It came more as an organizational concern, and a way to manage complexity, right? So in many ways, your software structure would mirror the organizational sort of boundaries that were there. And these things were very loosely defined, right? And then microservices kind of take this idea and say, hey, we'll have this bounded context. We can use this domain-driven design, and we'll have like clear separation of concerns, right? So when I tend to think about it, I look at it more like, okay, you can have all these things, but it's really about the how big or small you want these services, how clear you want these concerns separated out, so that you can manage complexity. And the point I want to emphasize here is, now you're starting to enter into the world of distributed systems, uh, where things like network partitions are more common, and failures are a given. And as you scale, you'll get more and more of these failures. Your context that you have for your larger problem is now distributed across services, and your troubleshooting complexity kind of just went up. So your monolith still had one distributed boundary, which is maybe your services and to your database, but now you have a lot more. And because now your context has been distributed, you now need to have very high unit test coverage, because when you're solutioning and the same logic which is there sequentially in your monolith is now distributed across various boundaries. And the big challenge that comes as a consequence of that is also that the unit tests are really your saving grace. If you don't invest in unit tests and you start doing microservices, then over time what also happens is uh, engineers come in and go. The new engineer comes in, he makes a change, that same context that is there, even though you have loose coupling and all the things, logic is separated out. Ultimately, if you're solving a business problem, that logic is now kind of spread out. So that engineer may not know who else is dependent on this functionality, even though you might have clear contracts. Ultimately, software is a bunch of special casing that and fine tuning over time. That context has to be captured in the unit testing. So anybody who does microservices without unit testing in the longer run is just asking for a lot of trouble. And the way you communicate across microservices, now that you have a distributed system, you need to look at patterns like any synchronous patterns, like an orchestration, or maybe some kind of an asynchronous pattern like queue-based, uh, uh, which like a Kafka or any other queue-based mechanism, asynchronous mechanisms to scale. Your deployment complexity also went up. You now have containers, uh, and then maybe you're using Kubernetes or some other technology. You're looking at continuous integration, continuous delivery. Observability becomes very critical. Monitoring metrics become very important for you to start seeing the larger thing, because there are a lot more moving parts. And then if you have like transactions, you can break it into patterns like Saga. You can break up the larger transactions, and there are other patterns like you can check out like CQRS, which is separating of read and write paths. We will look at that later. Uh, so this is sort of what life looks like once you venture into microservices. And the reason this is interesting to notice, uh, this is like not an uncommon scenario for a large company to have like hundreds, thousands, tens of thousands of microservices. And so that is what life will look like over the years. But this is like saying like, hey, this is what the universe looks like. This may not be interesting from an engineer's point of view. What is more interesting is how does this impact your life? And that is the relevant part that is of consequence from the engineer's point of view. It's not uncommon, for example, when you're doing e-commerce, to have hundreds of services that you're dealing with. And this also means that we started with it being an organizational context, right, to solve, to contain. It also means that while you're building software, a lot of your time possibly is also going in trying to figure out how to manage dependencies, how to do cross alignment between teams. If, for instance, your solution requires change in 6 services across, the company, if those services are with you, slightly easier to coordinate between teams. But if it's across the company, then everybody is also going through a prioritization. And this is something that you see in larger companies. Some of that complexity, the organizational complexity, also hits you. You need to maybe get TPMs in place, and some of this alignment, and then prioritization has to happen. Planning has to happen. So those are the non-software aspects of it. And then you're also getting into a distributed system where failures are likely to be more, and which is what we'll see in the second part of the talk, which we'll get to in the latter part. So what are the other considerations to consider while doing services? And these are things which people often overlook, which is having like a service definition. So having tenets for the service. Now, what does that actually mean? If you are writing a service and you like a new one, it's good to write down what the service will or will not do. And the reason for this is simple. Like when normally I've seen people come up with services, They just create a service. They say, okay, here's the service. Approximately, this is what we'll do. And then over time, that service didn't have a very clear definition, and it had a strange name. And every company has got like genus, and you no longer know what it does. So if I have a name like Panacea or something like that, uh, it could be doing anything and nothing. So over time, what will happen is, like you saw in the previous slide, you can land up with hundreds and thousands of services. And then when you start getting into conversations about what your service will do or what their service will do, you need to be very clear about those boundaries. And this is something people normally don't do. And that's when you start getting into conversations about where the boundaries are, it's not so clear anymore. The other things which don't happen very often is also like standardization of API naming, the way you do validation, the way you call out the parameters, because it's also in this service-oriented architecture. A lot of microservices, it's a lot of the decision making is decentralized. So because the decision making is decentralized, everybody is making their own decisions. So people decide how to name things for their own favorite way. I haven't come across a standardized way to do it, but if this is something that your company is kind of getting into, it's good to agree on some set of rules. Is that if not, it makes it hard as you're going across service boundaries. Things could look very different. The other part is the testing philosophy, popularized, I think, by Google, like a 70-20-10, where 70% of your tests are small, 20% are medium, and 10% are large. And here, when I say 70% are small, I'm saying you can do unit testing, and 20% medium can be your medium integration tests, which mock out some of them and keep some of the other things, and your large as proper integration testing. And the reason to break it up this way is it's very easy to go deep in the 70% case. And when you have a lot of tests running, it's good for you to get large amount of coverage from these smaller tests and go deep, rather than trying to drive all your end-to-end scenarios very deeply through integration tests. This is something I've seen a lot of startups not understand or get it right, where the philosophy is that QA will write all the tests, and the developers will do a lot of development. And so they try to drive everything through integration tests, and they tend to be very costly, right? And you can't go deep into all the corner cases. So this it's important to understand that you can achieve the same code coverage, even though you don't have to exercise all the code paths for your integration tests, and you just exercising the integration paths, whereas the deep cases you can cover it through unit tests. And that mindset is what this is about. So and like I mentioned before, you need a very high unit test coverage. So people don't seem to invest enough in unit tests, like coverage is below 40%. All I would at least say that 70% should be the coverage, or beyond that 85%, as much as you want. But if you start to go low, then you're basically picking up potential problems. And service discovery is the other one. Like when you have so many services, how do you discover or find services? And also things like service mesh, which uses some kind of sidecar pattern. All the traffic kind of goes through this mesh. So you can, because you're now in a distributed system, you can now do things like inject failures. You can see what happens when things fail, right? So which I'll be covering later. Anyway. So let's, with that context, let's look at a few scenarios. And I would suggest to look at these scenarios maybe once we are done with the talk, to relook at these cases. So let's say I'm in an early stage startup, right? And I'm trying to just get in. What should I do, right? I have a very small team. I have junior engineers. My product market fit is not clear. Should I do a monolith or should I do a microservice? We will look at that in the next slide. Scenario 2 is I'm scaling up beyond a product market fit. Maybe I have 15-20 member team. Maybe I'm a little bit wiser, a little bit more mature, and I'm still trying to figure out in this phase what should I be doing. At the third scenario is like I need to scale. I built my product. I know that scale considerations are there, and I have enough capacity. So let's just look at these scenarios from this viewpoint. Here, I've kind of drawn what I think is like a continuum and just trying to organize it in terms of where things could fall. And there's no hard and fast rule, but this is how I look at it. Like if I have an internal tool and I don't have scale, Monolith might be fine. Now you might say, hey, you know what, I'm this engineering company, I have the resources, I want to do it, I do not want to build a monolith. That's fine. I mean, maybe then you want to do whatever you choose to do and you can afford to do. But by default, uh, and as we look at the latter part of the talk, you are also trading off a lot of complexity, for ease of working with a non-distributed system or a limited distributed system in the monolith. Uh, Whereas as you start moving to the right, in the middle, I have services where as you start duplicating functionality, let's say like your startup started, and in our startup, when we started with like about 4 services to begin with. And now in 2 years, we have about 34 services, maybe 100 engineers, 150 engineers. So we're slowly starting to say that, hey, you know what, as we find things that are repeating, I don't want to duplicate the same functionality. So I want to have services. And on the right hand side, we are starting to go slowly towards internet scale. And I'm also moving to the world of distributed systems. I'm going to have large number of services, large number of teams. I need to have DevOps team. I need to be able to manage this complexity. And so that's kind of when I'm starting to look on the right hand side. Here's a very simplistic slide on how am I moving from the monolith to the microservices. Simplistic, I say, because people have written books on this topic. But this is like a very intuitive way to look at it, that if you started with a monolith and let's say you did modules, which is what I would suggest to do, then as long as you're not taking dependencies across your database, like it's in a monolith, it's very easy to say that you do joins in a database, and then you will have something that is touching across the database, right? Like referential integration, integrity issues if you have a relational database, and things that cut across the database. So you have joins. So you'll have to start partitioning those things out. As you break out your components, you split your database, and then you have to figure out how to move your monolith, break it up service by service. You kind of pull it out. Maybe you'll start with a small service to reduce your risk, to test the waters. You look at the ROI, say, hey, which is the thing that is not scaling, and then you move that part of it out. And the one thing is that you need to have business continuity over here. And because you want to have business continuity, you don't do a big bang. You just do it as you need it, and do it over time. So now we switch over to the second part of the discussions, which is what actually happens. What are the challenges that you're going to get now that you've decided to venture into the microservices? Let's start also looking at what are the challenges that you get in distributed systems. So I have a few examples with me where I'll talk about actual problems in terms of what we did in some of the startups and what we missed, and what are some of the learnings that I'm sure some variants of this also apply to a lot of the engineering that is folks would be doing. So we had this shared notification service that we would have, where in a normal day I would use this notification service maybe to send out like a WhatsApp notification or an SMS. So I'll have a bunch of providers. So the notification service, you can say, whom do I want to send notification to? I'll have a set of providers, because and I'll have more than one provider for the same type of service, because sometimes maybe one provider could be down, and I want to send out some kind of a communication. Now, in a normal day, all these things work well, but we found that suddenly, our marketing team wanted to do this bulk campaign was scheduled. So, okay, great. Then we sent out a large number of messages out. And normally what happens, the way it's architected is we get a callback from the partners, and then that message, that acknowledgement message is finally returned to a database. Very simple stuff. Uh, so we found our partner was down and we sent them a large number of messages. In some cases, I think they were just queuing the messages on their end. And then when it came back up, at some point, we got bombarded with a large set of messages in our callback. We had auto scaling kind of turned on, but even though we tried to auto scale the instances, we found that the database was not scaled up. Okay, we said, okay, then that effectively, as we started scaling up, we started choking on the database. And why I tried to auto scale was because there was someone like a couple of weeks before that had checked in some code where they missed an index. And so the update that was happening was had degraded the performance. So now what is it that I wanted to convey over here is normally I've seen like systems don't really go down because of any single thing. Maybe it's resilient enough to handle that. Now here itself, like if the DB had been scaled, maybe I would still be okay because my callback, I would still be able to process the callbacks fast enough. Had the indexes not been missed, and this is like a common thing which I've seen in multiple startups where a new engineer comes in, they are not aware that you need to have indexes in the database, so they check in some code, and you don't have observability properly done. You're not monitoring things, and over time that the database degradation starts to happen. So you can turn on like slow queries to check what is the performance of these things. You can have anomaly detectors in place, for instance, if you want to say that is the API latency changing week on week, and then you can have it smart enough to, if you're able to respond fast enough, then you never run into these problems, right? And or you're able to have these problems corrected when they happen, or not at a later point in time. These things are generally not set up so well. And also, we could have maybe when the the callback got a call, we could have maybe put it into a queue, right? So that it would have also taken care of increasing the scale. And ultimately, there is no rate limiting for the traffic. Now you can say, hey, should I have a rate limiting at all? Shouldn't I allow sensitivity for the callback messages? Possibly yes, but maybe you set a very high rate limiting, because at times we found when you don't put rate limiting, oftentimes mistakes happen, and let's say accidentally that you had a bug in your partner and it just bombarded you with like tens of thousands of messages, then your system is kind of go down. So you just need to be sensitive to that. The next example I have is of a classic example where I have like a third-party payment gateway that I'm using. So I have an API gateway for my APIs. So my app will call my API gateway. My API gateway calls my payment service, and my payment services then talk to a third-party, let's say payment gateway for processing payments. And one common pattern that we've seen is this third-party payment gateway goes down once in a while, right? I mean, it's ultimately a piece of software. So people are worried that like some of those APIs can take a long time. So the first thing that they do is they increase the timeouts. They say, okay, I'm not sure whether this will execute in a couple of seconds. Why take a chance? Let's make it 60 seconds timeout. And this is very commonly done. Now, on a good day, things are working fine. You don't really have any problems. But on that day when things are not working, suddenly what you find is things are starting to pile up at the gateway because it is down. And this payment service that we have is starting to slowly choke. And basically, you are even though you have auto scaling and all this is turned on, you start seeing that you're slowly getting contention for resources. Like the way the pattern is set up, we call the third party payment gateway, and they acknowledge us at some point in time. Similar pattern like we saw in the notification service. This particular pattern is like of a blocking call, but we also have some acknowledgement back and callbacks. So effectively what happens is your auto scaling kind of is failing because more and more requests are starting to pile up. And suddenly we found that one of the APIs that was doing some processing was also starting to scan the database, taking logs. So we started seeing a lot more contention. And so the simple thing could have been you just had a circuit breaker, right? So if I come back and look at this, if you have to see in terms of where you need to actually look at the thing in terms of scaling, you could have used like a circuit breaker so that you were decoupled from your dependencies, and thus you didn't run into this problem in the first place, so that when the payment gateway went down, you were protected. Or you could have used asynchronous patterns like a queue-based system to scale. And similarly, like some of the callbacks that were hitting us and causing contention for some of the database, we could have also protected from saying that, okay, this is what my system can do, very similar to the previous case. So the next example I have is around basically the similar pattern, but slightly different context around that, where when you have a shared API gateway, one of the things that we found, like in the previous example, just to extend that, when my payment services started experiencing some kind of outage, because I have a shared API gateway and have multiple services, as a startup, we can't afford putting everything separately. So it also side effects other services. So this is like a shared gateway kind of a pattern. Again, similar things that circuit breaker and some resource isolation patterns can be used. But again, being sensitive to the fact that if you made a decision to have not use things like circuit breakers and have large timeouts, that has a lot of cascading effect on other systems too. And the reason I bring up this pattern most importantly is, in a distributed system, it is not, you need to protect yourself from upstream and downstream. Upstream and downstream, because like, let's say I have an app, and if my app calls some service behind the API gateway, and that talks to some service that is down, and we actually saw this in an instance where the service was temporarily unavailable, then the user started seeing that the app was not behaving, and they had a retry button. And what is the logical thing that anybody is going to do? They're going to hit the retry button. And so during the outage, people were just hitting the retry button. Had you used a circuit breaker over there, it would have protected the downstream systems, as well as if those systems also had rate limiting, they are protecting from others bombarding you with like requests, right? So these patterns are extremely important. And now I'll talk about things from an order processing point of view, like how large companies, like if I take like an e-commerce player, trying to break down a larger order processing into smaller parts. So you can imagine that you're going to your neighborhood shop, you're going through items in the store, you decided to purchase some of the items in the store, you decided to make a payment, you took some of the items, and then you finally make a payment, right? So in the real world system, this entire thing is not really a transaction, right? It's not just one atomic thing. You did a series of steps, and that's how large e-commerce players are able to scale. They break the larger set of steps into smaller steps. You add into the cart, and then you basically take the order. You orchestrate the entire thing with the workflow, and then if the payment succeeds, you let the order go ahead, or you say, let's roll back this transaction. So it's like a business transaction, and this is where some of the patterns like Saga kind of can be used, which to break the larger part. So you stop thinking in terms of database transactions, because now we are looking at scale, right? All the things that you did, uh, the more RDBMS style thinking, if you put all those things, don't work so well. As you start to scale, you need to break up your problems slightly differently. And the last example that I have is, let's take this to a different type of scale. Let's say at cloud scale. Let's say I'm a cloud provider, and then I'm trying to deploy something like a compression feature for my database. Now, I'm not going to do a rollout for a compression feature for database in the cloud to all my customers, right? Possibly my database are running on thousands or tens of thousands of machines, right? So I'll have to try it out. So this is where cell-based architecture patterns are very interesting. It basically, the fundamental principle it is based on is blast radius and containing the blast radius, right? How do I make sure that I can keep the blast radius restricted and controlled, right? So, so thus you identify fault lines. You try to say that these group of things are within one kind of a containment zone or a deployment zone, and you split it. So in case of the compression example, I might say these small set of this small cluster I have of so many machines, I will turn on the feature and I'll test the compression. This will not impact any other of these services or database deployments that are there. And once it's tested, and slowly you'll roll it out, right? So this lets you basically manage the risk that kind of comes in. And they'll also use this for things like deployment, right? You're not like, how do you do deployment for tens of thousands of machines? Basically, you have to manage that also. So this is that pattern. So this is the last slide and kind of the summary of what all we discussed. And the thing I wanted to emphasize is, if you're into microservices, you want to think about non-functional requirements a lot more, and error handling, which people don't think about. Scale considerations kind of come last, or even resilience considerations come last. And it's logical from the point of view of the engineer, right? The functional requirements are what they need to deal with and to do. But some of these patterns are also very low probability events. For example, suddenly service one talking to service two is not visible. So you don't normally see that. However, when you start scaling all these low probability events, and every time you have a distributed system, the more number of such parts that you have, then it is just that the probability of failures have just kind of started to add up. And so invariably, one or other of these things are starting to happen across the boundaries. So it's very important to think about this as you scale, or if you want your software to be resilient when things go down. You can use patterns like workflow or retry mechanisms, and like in the order processing system I mentioned, maybe like a binary exponential backoffs with jitters. So what jitters are essentially is some kind of a randomness, because when you do like a retry strategy with the binary exponential backoff, both of y'all, if two guys, two systems were trying to do a backoff, they're going to back off at the same time, and they're going to come back at the same time. So when you do jitters, they don't come back at the same time. There's some randomness added. And this is also an important pattern. Normally, I've seen that if, especially when people have dependencies on some service, which is a third-party service, or some other service which is not working well, they say, and they know that it sometimes work if you can try again and again, right? So they'll go ahead and they'll try, right? They won't tell the other person. They'll say it's any of the other person's problem if the service is not working well, and they try multiple times before it fails. Now it might be okay, but if every layer starts to do the same retry strategy on a bad day, that service, which is a common service and shared across multiple clients, every single client will have a retry strategy, and at every level they'll have a retry strategy. And effectively what happens is, you're part of the problem now when that service is not behaving. It's slow already, and then you're hammering it because it did not give you the request. You have retry, multiple retries, and there are n such clients, And that service, if it doesn't have rate limiting and protecting itself, is just going to get bombarded and kind of go down. So that's something to watch out. Circuit breakers also already covered. Don't do long timeouts and dependencies because it affects availability. You can use queues to prevent partial failures, and make sure that you use some kind of rate limiting to protect your systems or IP whitelisting, because the other person, like I just gave the example where if your system is not working well, and this is something I've seen very commonly in multiple companies, is there's always one support person who comes in and some business person says, hey, I need to do this migration. They come in and they say that, okay, let me run this small script. They'll try it out for a few records, and then the business person kind of comes and says, hey, can you do it for 1,000,000 records? Can you make it fast? How fast can you go? So the support person says, okay, let me see. The system didn't have any problem. I tried with so many records, so I'll just up the number, right? And you just up the number, and suddenly you find that same system is also being used in production, right? And there was no rate limiting in place, and the system went down. And this is a pattern I've seen like in large organizations, because what they say is, your internal system, I don't need to protect you from internal. I'm only behind the load balancer. Externally, I will have some kind of a mechanisms. Internally, nothing needs to be done. Some of those assumptions that you're making are no longer valid. The other ones I mentioned, like missing indexes in production, these can cause availability things because the database is going slow. Sync versus async patterns to scale. The other ways to scale is read-write separation of paths. So you can have multiple slave databases so that you can kind of scale on that. And Saga for transactions, large transactions already covered. And lastly, fail fast option in customer path. Like in the case when I cannot do anything, it's better to just fail, right? Like for example, let's say I have this hyper local grocery or delivery or something I want to have, right? Now I know my systems are down. There's no point in me taking an order, and because I cannot really do anything about it. And but if I can take the order and there's no consequence of that, maybe I'll put it into a queue, right? So this depends on the use case, and it's definitely an option to consider. So I will end the talk here and open it up for any Q&A. One thing I would encourage people to kind of go back to the slide which was on the decision making, right? Now that we've covered, and this is just an introduction, we've kind of got into distributed systems. These are the commonly occurring problems. What would your decision be when whether you want to do monolith or microservices, and whether you would really want to do it or not? What is it that you're trading yourself, the trade-offs that you're kind of getting into considerations? That is something for you guys to consider.